So far on today's show, we've learned how data collected by the hurricane hunters helps meteorologists at the Weather Channel predict hurricanes.
But what about NASA?
What does NASA have to do with hurricanes?
I thought you'd never ask. Without NASA, or the National Aeronautics and Space Administration, we wouldn't be able to see Earth from space. NASA's bird's eye view of our planet has revolutionized observations of the Earth's atmosphere, continents, and oceans. A few years back, NASA launched geostationary satellites that monitor the weather above the Earth. Geostationary means that the satellite orbits the Earth at about the same speed the Earth rotates. The satellite collects weather data as it hovers over the same point on the Earth. The data is then sent back to Earth for our use. Thanks to NASA, today there is a worldwide network of satellites above our Earth, collecting weather data over the whole world and transferring these data back to us on the ground. But NASA is always looking towards the future, towards developing new and better technologies for observing and predicting severe weather, like hurricanes and tornadoes. We're here at the NASA Langley Research Center in Hampton, Virginia, to meet a scientist who's developing a gift for future meteorologists.
How would gifts provide a more complete picture of the Earth's atmosphere?
How does remote sensing work?
What does the information collected about the water vapor tell us about a storm?
NASA Langley Research Center is developing a new technology which will allow meteorologists to better predict how strong a hurricane will be and where it will come ashore. Scientists like me are working with professors and students at the University of Wisconsin and at the Utah State University on the geostationary imaging Fourier transform spectrometer. Now, because acronyms are easier to say, we call it the GIFS. GIFS is actually an instrument that will be flown aboard a geostationary satellite about 22,000 miles above the Earth. We believe our new technology will be a gift to mankind in that it will enable people to avoid the loss of their property and even possibly their lives by warning them of approaching hazardous weather such as tornadoes and hurricanes.
Okay, but how will GIFs improve weather predictions?
Well, GIFs will provide meteorologists with a complete picture of our Earth's atmosphere. Currently, upper air observations like temperature, water vapor, and wind are obtained by launching weather balloons. Every day, twice a day, these balloons rise through the atmosphere and collect weather data over land areas. However, the balloons are spaced very far apart and give us only spotty data. GIFs will collect the same data from space every 10 seconds, over land as well as over the sea, where hurricanes come from.
Wow, every 10 seconds? Dr. Smith, how will it do that?
Using new infrared digital camera technology, GIFs will have several thousand times more sensors than current satellites to measure atmospheric temperature, water vapor, and wind. Let's take water vapor, for instance. Water vapor is actually water in its gaseous state, so it's invisible to the human eye. When water vapor molecules become liquid water or ice crystals, a cloud forms. Current satellites measure water in the form of clouds, but they do not measure very well the water vapor that causes the clouds to form. Being able to sense the water vapor before clouds form will allow us to predict how, when, and where storms will form and where they will go.
That's great. Sounds like GIFs will provide meteorologists with information on hurricanes even before they form. This can only help save more lives because the more forecasters know, the quicker they can warn people on the coast. But you keep saying that GIFs will sense water vapor. What do you mean by sense?
Oh, good question. GIFs measures elements of the atmosphere like temperature and water vapor without touching them. It's called remote sensing, and our eyes do it every day. Your eyes can sense or measure how a person is feeling without touching them. All you need to do is look at them, and you'll be able to tell how they are feeling.
Oh, okay. I understand how people sense things, but GIFs is an instrument. How does it sense water vapor?
By using an infrared camera. Let me show you. This picture of a man in glasses was taken with an infrared camera, seeing through the air and sensing only hard, solid objects like the wall, his face, and his glasses. Here we see the brightness of the man's face and the darkness of his glasses. This means his face is giving off heat and is relatively warm, whereas his glasses and the wall are not giving off as much heat and are therefore relatively cold. This picture is a good example of what current satellites can see from space. The second picture was taken with an infrared camera, seeing air molecules as well as hard, solid objects. Here we can see his breath exhaled from his mouth. This is because the infrared camera senses that his breath, which contains water vapor, is warm relative to the cold wall behind it. The second picture is a good example of how GIFS technology will improve weather detection.
Hey, you said the water vapor in his breath is warm, so I guess that means it gives off heat.
Yes, both water vapor and clouds give off or radiate heat. GIFS can't feel the heat, but being an infrared camera, it can sense the amount of heat the water vapor radiates. An analogy is when you close your eyes on a partly cloudy day. When the sun comes out from behind the clouds, you don't have to open your eyes to know the sun is there. You can sense or feel the heat of the sun radiating on your face. Speaking of heat, remember the graph Valerie showed you? Heat, but specifically temperature, is an important variable when describing what is going on in a hurricane. GIFS will measure the heat from water vapor even before clouds form. This will allow us to predict the formation and intensity of upcoming storms, like how much rain will fall or how severe the winds will be.
Cool! Hurricanes are known for their winds. Will GIFS sense winds too?
Absolutely. Dr. Lyons told us earlier that the steering winds determine where a hurricane is going. There are very few clouds away from the storm where the steering winds are. GIFS measures the movement of the water vapor at all altitudes. These motions are the steering winds which determine the speed and the direction of the hurricane.
Well, Dr. Smith, GIFS really is a gift for forecasters and for people who are affected by severe storms like hurricanes.
That's right. In fact, NASA Goddard Space Flight Center in Greenbelt, Maryland is working with us to integrate GIFS technology on future weather satellites. Visit this website to learn more about GIFS technology and NASA's dedication to help science better understand our planet.
Thanks, Dr. Smith. You know, future NASA technology like GIFS will provide us with more accurate satellite measurements. By combining GIFS technology with the data from the hurricane hunters, meteorologists like Dr. Lyons will be better able to predict hurricanes and help save lives.